Hey, let's cover section 5.5, zeros of polynomial functions. So we're going to use synthetic division. Do not think it's anything like regular division that you've been avoiding to this point. It's much easier. I'm going to show you. You'll have it down within a few tries of doing it on your own. I have found that it's the easiest way to divide polynomials by a binomial. So let's do it. So we're going to use synthetic division to find the quotient and the remainder. All right, so if you're given a polynomial divided by a binomial, all right, what we're going to do first is take that binomial, x plus 2, and set it equal to 0 and solve for x. So we're going to subtract 2 from both sides, and we get x equals -2. All right, so for synthetic division, you're going to take the -2, and then instead of doing it like this, we're going to go under. Now, the first thing that you need to think of is, are these in order from highest to lowest, and are all x's represented, x's and constants represented? So we've got x cubed, squared, the first, so we're good to go. So I'm going to just take each of these coefficients and write them down. 2, -3, 4, and 5. Okay. The first thing you do with synthetic division is you bring down the first number. Done. Now, from here on out, it's all exactly the same. -2 times 2 is -4. You do not change signs or anything. We just add them up. -3 and -4 is -7. -2 times -7 is +14. 4 plus 14 is 18. -2 times 18 is -36. 5 minus 36 is -31. So the remainder in this case is the -31. We've got a remainder equals -31. All right. To verify that this is correct, we're going to just plug in f of -2. And I want to use my whiteboard because I don't want to use up all my space here. So f of -2, I'm going to plug in -2 only for the polynomial. So if my polynomial, let's get rid of that light. If my polynomial is 2x cubed minus 3x squared plus 4x plus 5, I'm going to plug that -2 in for all of my x's. So this is f of -2, which is 2 times -2 cubed minus 3 times -2 squared plus 4 times -2 plus 5. And we just need to combine these. So this is 2 times -8 minus 3 times 4 minus 8 plus 5. -16 minus 12 minus 8 minus, I'm sorry, plus 5. And I need a calculator. Hold on, I'm not prepared like a regular student. All right, so -16 minus 12 minus 8 plus 5, and that is -31. So we just verified that our synthetic division is correct. All right, -31. So f of -2 is -31. All right, next one. Now you're going to have to do the synthetic division on your exam. All right, so don't just think that you can solve for the x and substitute it in for the polynomial. I need to verify that you can actually do the synthetic division. Okay. Sorry to burst your bubble. Next victim. We've got x plus 4 as the denominator, as the divisor. So x plus 4 equal to 0. I'm going to solve for x, subtracting 4 from both sides. X is equal to -4. So -4 is going to be my divisor. And then I'm just going to make sure that we have all of our x's first and all of our constants. So we've got x cubed, x squared. We're missing x to the first. So we're missing x to the first. And then we've got our constants. So I just need to write those down. -4, -1 for those two. Now, because we don't have an x to the first, it's going to be a 0 and then -12 for our constant. Start by bringing down your first coefficient, -4. Now, -4 times -4 is +16. -1 plus 16 is 15. Times -4 is -60. And then 0 and -60 is -60. And then 60 times, sorry, -60 times -4 is 240. And then 240 minus 12, I just don't want to mess this up for y'all. I think I've already got there, 228. So my remainder is 228. Okay. Now I'm going to do the find f of -4 into just the numerator, just into the polynomial, right? Again, I'm going to go to my, actually I can do that one down here. So we'll do f of -4, and I'm going to take -4 times x cubed, which will be -4 cubed, minus -4 squared minus 12. All right, so we've got -4 times -64 minus -4 squared is 16, and then minus 12. Oof, hold on. 4 times 64, I know they're positive, is 256. Minus 16 minus 12, minus 16 minus 12 is 228. So sweet, we got the same thing. We know our synthetic division is correct. Okay. All right, last one. We've got 3x cubed. Oh, we're missing the square. So we've got a 0x squared and then plus 2x minus 5. First, we need to take our x minus 1, set it equal to 0 and solve, add 1 to both sides. X is equal to 1. So I'm going to take 1 and synthetic divide it into my polynomial. So 3, 0, 2, and -5. Bring down your 3 first. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. 2 plus 3 is 5. 1 times 5 is 5. And then -5 plus 5 is 0. What this means, because we got a 0 for a remainder, just like it means for regular division, if you get a 0 for a remainder, that means it's a factor of this. So this x minus 1, if you think of, we're going to factor it or solve for quadratic or something, x minus 1 is a factor of the polynomial that's on the numerator. So let's do find f of 1. I'm going to take the 3x cubed, so 3 times 1 cubed, plus 2 times 1 minus 5. Well, 1 cubed is just 1, so this is 3 plus 2 minus 5. 3 plus 2 is 5, minus 5 is 0. So yes, we got the same thing as the synthetic division. All right, next victim. If a polynomial, this is the remainder theorem, it has to do with this. If a polynomial, f of x, is divided by, what are we doing here? X minus k. Then the remainder is the value f of k. That's what we just proved. Use the remainder theorem to evaluate this polynomial at x equals 2. All right, we're going to use synthetic division. In this case, we don't have to do this part in solving for x. They've already done it for us. So we're just going to put the 2 out here. We need to make sure that all of the x values and the constant are represented. 4, 3, 2, 1, we're good to go. So write those down. 6. If you do not have a number in front of the x, remember it cannot be 0. If there was a 0, you wouldn't have the x. So it's -1, -15, 2, and -7. First thing you're going to do is bring down 6. 2 times 6 is 12. -1 plus 12 is 11. 2 times 11 is 22. -15 plus 22 is 7. 2 times 7 is 14. 14 plus 2 is 16. And then 2 times 16 is 32. And -7 plus 32 is 25. All right, so that is our remainder. So f, what this means is that when you plug in 2 for that polynomial, f of 2, you're going to get 25. This is the remainder. And that is showing that it's f of k. So when you have, if you would solve this, this is x minus 2 equals 0, x minus k, 2 is our k. So that's the remainder theorem. Now we didn't do this one in class. I didn't have time to do this one in class, but I want to make sure that you have, now granted, this is my summer class, so this video may be used for a later class. And if so, hopefully we had a chance to do it. All right, they've already solved for -3 for us. So let's just plug in our -3 here. Make sure we have all of them. 5, 4, 3, 2. We're missing a 0x. So we need 2, -3, -9, 8, 0, and 2. They have to be in order, y'all. It's not going to work otherwise. So bring down your 2. -3 times 2 is -6. -3 minus 6 is -9. -9 times -3 is +27. -9 plus 27 is, did I do this one? Yes, I did. 9. No, that's not right. Hold on, I got different numbers here. Oh, I did it wrong on my paper. Good for me. Oh, humans. 27 minus 9, 18. That's what I thought it was. And then -3 times 18, -54, plus 8 is -46, times -3 is +138, plus 0 is 138, times -3 is -414. It's getting crazy here. And then plus 2 is -412. Yeah, that's totally what I got. So f of -3, because this is the remainder, is -412. I need to fix that. I'm going to pause real quick. Okay, now we've got our factor theorem to where k is a 0 of f of x, so it's an x-intercept, if and only if x minus k is a factor, is a factor once, is a factor of f of x. So if k is a factor, the remainder will be 0. Zero. Right? Example 2. Using the factor theorem to solve a polynomial, show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Find the remaining factors. Okay, now we're finding it. Use the factors to determine the zeros of the polynomial. Okay. So the first thing we're going to do is synthetic division. I'm going to do it over here to the left because I'm going to need a little bit more space. So x plus 2, set it equal to 0 and solve. Subtracting 2 from both sides, we get x is equal to -2. So for synthetic division, we're going to use -2 as our divisor. Make sure we have all of our variables, 3, 2, 1, we are good. Coefficient of x cubed is 1. We've got -6, -1, and 30. Bring down your 1. -2 times 1 is -2. -6 plus -2 is -8. -2 times -8 is 16. -1 and 16 is 15. -2 and 15 is -30. And that is 0. So what that means, -2 is one of our zeros. We need to find the other one. Now, our highest exponent, our degree here is 3. So if our degree is 3 and we just divided it, that means that this one is going to start off with the next one down, which is x squared. So this is 1x squared minus 8x plus 15. Okay, you can only do that if you got a remainder of 0. All right. So now we have this trinomial to factor. I'm going to write it up here. I'm going to set it equal to 0. X and X, 5 and 3. They're both negative because the middle term's negative. Set each of these equal to 0. Add 5 to both sides. X is equal to 5. Add 3 to both sides. X is equal to 3. And then we also have X is equal to -2. Those are our zeros or our factors for this polynomial. Okay, those are going to be the intercepts. Let's talk about another theorem. If f of x is a polynomial function with integer coefficients, which means no decimals and no fractions, then every rational zero will be in the form p divided by q. I'll explain it. Where p is the factor of the constant term, in this case it's our 30, and q is a factor of our leading term. In this case here, it was 1. So let's do this. Example 3. List all possible rational zeros of the polynomial. So the first thing I need to know is what's the constant? What is the constant? Because the constant is going to be in relation to our p. Okay, our p is going to be for our constant. And our constant is -4. So now I need, what are the factors of -4? Well, those are plus or minus 1, plus or minus 2, and plus or minus 4. Now for our q that we're going to be using, I need to know what is my leading term. What is my coefficient of my leading term? My leading term is 2x to the 4th. Also make sure they're in order to where you know that's your leading term. So 2x to the 4th, I just need the 2, and my coefficient of my leading term, write it all out if you need to, is 2, and I need to know what my factors of 2 are. In this case, it's plus or minus 1 and plus or minus 2. All right, now we know that p can be plus or minus 1, plus or minus 2, and plus or minus 4. Q is plus or minus 1 and plus or minus 2. I need to look for each one of these as p over q. All right, I'm going to keep it as plus or minus though. So for p over q, I'm going to take plus or minus 1 over plus or minus 1. And then plus or minus 1 over plus or minus 2. All right, I've done this one. Now I need to do this one, p over q. Plus or minus 2 over plus or minus 1, and plus or minus 2 over plus or minus 2. Last one, you need to do plus or minus 4. I'll come up here, need a little more space. Plus or minus 4 over plus or minus 1, and plus or minus 4 over plus or minus 2. All right, I just want to reduce these real quick just to make it look a little nicer, because it's just kind of crazy. So plus or minus 1 over plus or minus 1 is just plus or minus 1. All right, that's what that one is. Plus or minus 1 over plus or minus 2 is plus or minus 1/2. Plus or minus 2 over plus or minus 1 is plus or minus 2, because 2 over 1 is 2. Plus or minus 2 over plus or minus 2 is plus or minus 1. Plus or minus 4 over plus or minus 1 is plus or minus 4. And plus or minus 4 over plus or minus 2 is plus or minus 2. Try saying that fast. That's wicked. Okay. So finally, our possible, we're not finding them, our possible rational zeros are plus or minus 1, plus or minus 1/2. That helps if I write it a little bit better. Plus or minus 4, plus or minus 2, and these two are repeats. So that is my possible rational zeros. not even finding them. I'm just, what are my possible rational zeros? Okay, example 4. Using the rational zero theorem to find rational zeros. Now we're going to find the rational zeros. Here we were looking for the possible rational zeros. So now we're going to look for the rational zeros themselves. All right. So the first thing I want to do is know what my constant is. My constant is 1. My factors of 1 are just plus or minus 1. What is my coefficient of my leading term? In this case, make sure they're in order. It's 2. So what are the factors of 2? Must be nice. And they're plus or minus 1 and plus or minus 2. Okay. So now we need to find our possible rational zeros. So if P plus or minus 1 and Q is plus or minus 1 plus or minus 2, our possible rational zeros are P over Q, which are plus or minus 1 over plus or minus 1 and plus or minus 1 over plus or minus 2. Now this will reduce to just 1. And this will reduce to just cleans up nicely to plus or minus 1/2. Now I know how much y'all love fractions, so I'm going to start doing synthetic division with let's just do the positive 1 first, just to get started. Okay. Actually, I'm not going to do synthetic division. I'm just going to plug and chug. I'm going to plug it into the polynomial and see if it works, which is just the other option. So f of 1, and I get 2. I have to do all of these. I have to do all 4 of these for this one. I'm so sorry, y'all, just to show you. Plus or minus 1. So I'm going to put in 1 for first one. 2 times 1 cubed plus 1 squared minus 4 times 1 plus 1. 1 cubed is 1 times 2 is 2 plus 1 minus 4 plus 1. 3 minus 4 is -1 plus 1 is 0. Sweet. So 1 is our rational zero. So rational zero. There's 1. I'm going to put my list down here once I'm finished. I'm going to do the other ones on my whiteboard. Actually, I can break out my other piece of paper. Hold on. I got you. Now let's do -1. So f of -1 is 2 times -1 cubed plus -1 squared minus 4 times -1 plus 1. This is -1 cubed is -1. So 2 times -1 plus -1 squared is 1 plus 4 plus 1, -2 plus 1 plus 4 plus 1. All right. So -2, we can put it in our calculator. That's what you're going to be doing anyways. -2 plus 1 plus 4 plus 1 is 4. So this is not a rational zero because we did not get 0 for a remainder or for an answer. We have to get 0 for an answer. All right, let's do 1/2. So f of 1/2. Yes, you could use 0.5. 2 times 1/2 cubed plus 1/2 squared minus 4 times 1/2 plus 1. 2 times 1/8 plus 1/4 minus 4 divided by 2 is 2 plus 1. This reduces to 1/4. So 1/4 plus 1/4 minus 1, -2 plus 1 is -1. And this is equal to 2/4 minus 1, which is the same thing as 2/4 minus 4/4, because 4/4 is 1. Oh, running out of space. Which is -2/4, which is not 0. I don't even need to reduce it because it's not going to be a rational zero. And then lastly, let's do f of -1/2. And it is 2 times -1/2 cubed plus -1/2 squared minus 4 times -1/2 plus 1. 2 times -1/8 plus 1/4. Negative and negative is positive. This reduces to 2. This will reduce to -1/4 plus 1/4. This is looking good. Plus 3. Okay, these are gone. So my answer is 3. So this is not. So our only rational 0 is 1. I don't need a comma there. That's my answer. Okay. So this is one way to do it. We could also find the zeros using synthetic division. Okay. So the first thing we need to do when we're doing this, and honestly, this is going to be so much thinking easier, y'all, is we have to do what we did up here. What is the constant? And the constant is -1. And the factors of -1 are plus or minus 1. Then we need the coefficient of the leading term. In this case, it's 4. Our factors of 4. Plus or minus 1, plus or minus 2, and plus or minus 4. Pardon me. All right. Now, what we would need to do here is check each of these to see if they are rational zeros. I don't know which is easier for you. I like synthetic division. I think it's quite easy. But I also understand that if there's fractions involved, it wouldn't be necessarily easy. So P over Q, and I'm going to skip the whole lining them up thing. P over Q would be plus or minus 1 over plus or minus 1, which would just be plus or minus 1. Plus or minus 1 over plus or minus 2, which is plus or minus 1/2. And plus or minus 1 over plus or minus 4, which is plus or minus 1/4. So those are our possible rational zeros. We need to find which one it is. So I'm just going to start. I know you don't want to start with fractions, so let's just start with 1. Okay. So I'm going to take 1 and synthetically divide it into my polynomial. Again, make sure that you've got all of your x's represented. We're missing the x squared. So x cubed, x squared, there's my x, there's my constant. Bring down your 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. -3 plus 4 is 1. And 1 times 1 is 1. And that's 0. So sweet. That's freaking awesome. So we now know that our zeros, one of them is 1. X equals 1. There's 1. All right, now I can just take this trinomial. Remember, if it starts with a 3 here, that means this needs to start with x squared plus x plus 1. Because they didn't have negative signs, I threw the positive signs in there. I can take that 4x squared plus 4x plus 1, set it equal to 0, factor, and find my other zeros. 2, 4 and 1 won't do it, so it has to be 2x. 1 and 1. So there's 2x and 2x, which is 4x. Everything's positive. Oh, we have a binomial squared. Sweet. So 2x plus 1 equals 0. I only need to do 1. Same thing. Subtract 1 from both sides. 2x equals -1. I'm already dividing. Divide both sides by 2. So x is equal to -1/2. Now, what you need to understand is because there was 2 of these and I only had to solve for 1, this one is a double, so it has a multiplicity of 2. Okay, make sure you can understand that. We're still talking about multiplicities. All right, a couple theorems here. Any polynomial of degree n has n zeros. Now, we talked about before that degree is being represented by n, right? So it's going to have n zeros. We just might have to use complex numbers. All right. Linear factorization theorem, that was the fundamental theorem of algebra. Linear factorization theorem says that, what is it? Which also means that it will have n factors. And this is counting multiplicity. You always count multiplicity. Multiplicity. And what they're meaning with that is up here, where we only found 2 zeros. Well, our degree is 3. So 2 doesn't make sense. But if you bring in the multiplicity of 2, then we've got the 3. Okay. All right. Next page. You know what? I'm going to stop and create another video. I think that's going to be smart.